time to look at some applications of equations in section 2.2. Our first problem, the first bus has 12 more seats than the second bus. The third bus has 8 fewer seats than the second bus. The total number of seats is 154. Find the number of seats for each bus. So we're comparing 3 buses. We should write something down for that. So I'm just going to number them. The first bus, the second bus, and the third bus. Right, and when you're working with word problems, the one they say nothing about should be your variable. So when we read the first sentence, the first bus has 12 more seats than the second bus. They don't say anything about the second bus. When we read the next sentence, the third bus has 8 fewer seats than the second bus. This one also refers back to the second bus. So the second bus is going to be our variable. We will call it X. We're going to translate the other two. For our first bus, it has 12 more seats than the second bus. More than is to add. It doesn't matter if you write X plus 12 or 12 plus X. It's the same. The third bus has 8 fewer seats than the second bus. Fewer is like less than. It's going to go backwards. So the 8 is what you're going to subtract. So it's 8 less than the X. We'll use the other sentence to make an equation. The total number of seats is 154. So total means to add them all up. So if we add all these up, it should equal 154, and that will give us a nice linear equation. So there's our first bus, the seats on it, second bus, third bus, and it equals 154. Now you have a standard linear equation. Put your like terms together, so we have 1, 2, 3x. For your constants, will give us a positive 4. All right, and now we're going to solve. So working on the side with the variable, we're going to subtract 4 from both sides. And when we clean up, gives us 3x equals 150. Divide both sides by 3. So x equals 50. Now you need to answer for all 3 buses. So you're going to substitute the 50 back for the other 2. This is the second bus. Plug it in. So into the first one, 50 plus 12 will be 62. Also plug the 50 into the third one. 50 minus 8 will give us 42. Now we can do a quick check with numbers. 62, 50, and 42. Add those up. And it does give us 154. Problem 2. The price of a new math textbook is $118. What is the total price after 6% tax has been added? So we have to find a percentage. What is 6% of 118? This is going to be a multiplication. We can review it a little bit. It works with the formula P times B equals A. P is your percent. You always have to switch out of percent into a decimal. So drop your percent and go 2 places to the left. 0.06 times your base. The base is the thing you're taking the percent of. So it is 118. And you're finding out what is this percentage. The what is, that is going to be your A. The is your equals. So then we have an equation there. Do your multiplication. This is a good calculator problem. Make sure you get your decimal in. 0.06 times 118. And this gives us 7.08. And then we want the total price, so we have to add that to the original. Also, this is fine for your calculator. 118 plus 7.08. If you have to do it by hand, decimals line up, straight up and down to add or subtract, which gives us 125.08. But anytime you're going to find a sales tax that's taking a percent of something, it's a multiplication. Just remember to switch your percent over to a decimal. Problem 3. A new TV was recently purchased for $551.20, including tax. If the tax rate is 6%, find the price of the TV set before taxes. So they want to know the original price. This is a nice problem to do as an algebra problem. And percent increase or decrease problems work with this formula. So you have an original. If it's an increase, you add. So the increase is going to be my tax in this situation equals the final. And the increase or decrease normally is a percentage times the original. So what I know in this problem is the final, because it's $551.20 including the tax. So this is the piece I don't know. Now, I don't know the original or I don't know the increase. The increase is based on the original. So the original is the one I want to call my variable. My percentage is 6%. Remember, switch to a decimal. So 0.06 times my original, which I called x. So I also need an x here. Now you have an equation. Put your like terms together. Remember, if you don't see a coefficient, it's a 1. So 1 plus 0.06 is 1.06. X equals 551.20. And now you will isolate your variable by dividing by 1.06. Do this in your calculator. Make sure you punch it in top to bottom. 551.20 divided by 1.06 gives us 520. Problem 4 is also a percent increase problem. It says, in 2010, the population of some country was 1,200,000. From 2010 to 2060, the population is expected to increase by 30%. Find the expected population of the country in 2060. So we have an original. We're going to add an increase. And that will equal the final, which will be our expected population in 2060. So this time it is the final that we don't know. Right, our original is 1,200,000. Our increase, remember, is percent times your original. So this is going to be 30%. Drop the percent and move the decimal 2 places to the left. So 0.3 or 0.30, it's the same, times your original. And I didn't leave enough space here, so I'm going to squish it. Right, you have to follow order of operations. So you need to do your multiplication before you try to add. Plug this into your handy dandy calculator. And you're going to get 360,000. And now add that to your original to give your final. So you get 1,560,000 is the expected population.